combined variation and joint variation, but this is all there is. We're just going to build on these today. So just to remind you from yesterday, direct variation is y equals, and then you have some number times x. A direct relationship is multiplication with your constant. Okay, an inverse variation looks like this, y equals k over x. So an inverse relationship places your variable underneath the constant of variation or in the denominator of a fraction. A combined variation, it says when one quantity varies with respect to two or more quantities. This is basically going to be like direct and inverse within the same problem. That's all it is. And then a joint variation. This is multiplication, so it's going to be like a direct variation, but with two or more variables. Joint variation, if you see that, it'll say something like varies jointly, and it's just a direct relationship, but there would be more than one variable multiplied by your k value. So I'll just make up a little example. So maybe we'd have something like y equals, and then you would have k, and then you would have like two variables next to it instead of just an x. So maybe I'd have like an x and a z or something like that. But a joint variation works like a direct. It just is a special word if you have more than one variable multiplied by your k value. Direct is just one variable multiplied by your k value. Okay, so we're just going to translate these in this first example here. So it says y varies turns into an equal sign directly with the square of x. Okay, so I'm just going to change this into an equation. So I'm going to write y equals, and then just get into the habit of this. They're not going to have k, the constant of variation, as part of the description. So just immediately after you write the equal sign, just put a k to represent that so you have it. And this is not going to be a situation we're going to solve for k because we don't have enough information. We're just kind of doing a basic setup. And then it says directly with the square of x. How would you write the square of x? How would we write the square of x, like as a variable? What am I doing if I square something? Exponent of 2. Okay, my heart is like beating really fast. Okay, this is just x squared. Square of x would just be x squared. That's all it would be. Just x squared. All right. Now, if we do an inverse, that is the next one. It says y varies, so I'm going to write y equals, and then I'm automatically just going to put a k in there. Again, we're not going to solve, but we're just going to kind of set this up. Now it says inversely, so immediately when I see inversely, I'm going to put the k, and I'm just going to underline it because I'm going to put whatever variable follows underneath the k value. So an inverse variation is going to be dividing by whatever variable follows. And that says inversely with the cube of x. How would you write the cube of x? X cubed, right? X to the third. All right. You guys are super quiet this morning. All right. Now, these two, the jointly that I mentioned at the top today, it just means there's more than one variable that's going to be multiplied by your k, but a joint variation is going to be multiplication. So this one says z varies, so I'm going to write z equals, and just automatically, after you put the equal sign, put a k. And then jointly just means whatever variables they describe there. It says jointly with x and y. It just means that x and y are going to get multiplied together. That's what jointly means. It's direct variation, but it's more than one variable multiplied by your k value. All right, and then I've got one more. This says z varies, so z equals, and just automatically, right after you put the equal sign, just put a k in there. Don't forget that. And then jointly with x and y. So I'm going to write x, y, just like we did on the last question. Then this says and inversely. So if then you see the word inversely, we're just going to turn that whole thing into a fraction. Inversely with w, w is going to go on the bottom of that fraction. Is anybody having a question how I'm setting up any of these equations at all? Okay. Now, I've got actual formulas here, and we are going to try and kind of reverse what we just did. And we are going to write this out in words what this equation would be. Now, the one thing I'm going to have you guys do is tell me what you think the K value is, because the K value is not going to be involved in any of these descriptions. You're not going to see anything about what the constant of variation is when you describe these. So these are all actual formulas. This is the mass of a moving object related to kinetic energy, which is n, velocity is speed is v. This, maybe if you're taking physics, you would have seen this. So what would you tell me if you're just looking at this lovely equation, m equals 2n over v squared? What is the K value? What would your constant of variation be? Does anybody know? What do you think? So 2. If you see a number, the number is the K value. Okay, number is not involved in the description. All right, so I'm going to just write this like the other one. So you don't have to actually write out the words. I'm just going to write the variables, okay? So I have m equals. So I'm going to translate that. M varies. Now, on the top of the fraction, I have 2 times n. So just one variable, that's a direct relationship. So I'm going to say directly with n, and because I have a fraction, I have a variable in the bottom of the fraction, we have an inverse relationship there. So directly with n, and then we'll say inversely with, whoops, and then I'm just going to say v squared. You don't have to write out like velocity squared or whatever. Or the square of the velocity. You can just write v squared. That's totally fine. The second formula I have, this is the volume of a sphere, if you guys remember that from geometry at all. Volume 4/3 pi r cubed. Can anybody tell me what the K value is for volume of a sphere? What do you think? Yes, good. It's the 4/3 and the pi. That would be constant. Every time you would find the volume of a sphere, you'd use 4/3 and pi, and then you would have to find the radius or know the radius to find the volume. But the 4/3 and the pi are both the K value. That's constant every time. And so this, I know this is a little weird, but this is actually just a direct relationship because you only have one variable over here on the right side. You just have the radius. So to do this, I would just say volume, or just v, varies. And we'll just say directly, because we only have one variable being multiplied by that 4/3 pi, with your radius cubed. I'm just going to write r cubed. That's all you have to do. And then the last one, I think this is kind of tricky here. The last one says the formula for the area of a triangle. So I have area equals base times height divided by 2. Anybody tell me the K value for this formula? What do you think? Yes, 1/2. All right, so I don't know about you guys. When I learned, they taught it, it's the same formula, but I learned it like that, 1/2 base times height. Both of those are the same. But in this case, no variable, there is a fraction there, right? But the bottom of the fraction is a number. It is not a variable, so there's no inverse relationship here. These variables, base and height, are being multiplied. Because there's 2 of them, this has to be described as a joint variation. All right, so we're just going to say for this one it's area, so I'm going to say A varies. And only because there's 2 variables being multiplied by this K value, the B and the H, you have to say jointly instead of directly, because there's 2 variables there. Jointly with B and H, or base and height. And it doesn't matter for the variables whether you put the height first or the base first. It's the same either way, because if you multiply like 5 times 3, it's the same as 3 times 5. Multiplication is commutative. All right, is anybody having a question? All right, see if you guys can translate these. So I'm going to have kind of like 3 parts to this question. So here's the first part. It says Z varies jointly with X and Y. All right, Z varies jointly with X and Y. Can anybody just raise your hand, tell me, how would you translate that into an equation? So instead of words, Candace, what do you think? Thank you, thank you. Okay, now, they are going to then give you just enough information to figure out the K value. So like part 1, so part 2, we're going to plug in whatever numbers they give us. So z is 60. You don't know the k, but that's why it's very important. We're going to use this information to figure out what that is. X, we're going to just plug in 2. Y, we're going to plug in 3. Sometimes it might be a nice number. Sometimes it might be a fraction. It's just going to depend on the question. So this is 60 equals k times 6, right? So I would just divide by 6. That means k is going to be 10. Okay, then what I would have you do is just rewrite your equation just real quick, like step 3. You get kind of your setup. They'll give you numbers to figure out k. And then as your third step, let me just go ahead. I'm going to rewrite that original equation, but now that I know the k value, I'm just going to put that in place. Then they will have like a secondary question. So after you've set up the equation, it says find z when x is 4 and y is 9. So I'm just using that equation we just wrote. So we don't know z. My k value would be 10 every time. X is supposed to be 4 and y is supposed to be 9. And then we would literally just multiply that out. 10 times 4 is 40, times 9 would be 360. So these kind of have a couple answers to the question. There's that. And I need to do those steps in front of it to get there. Does anybody have a question? All right, let's see if you guys can try this one. So here's my setup. Z varies directly with x and inversely with y. Don't forget the k when you set it up. Who could translate that for me into an equation? Just raise your hand and tell me. What do you think? Z varies directly with x and inversely with y. What would that look like if we made an equation? Oh, don't everybody volunteer at once. What do we think? Yes, ma'am, go ahead. Perfect. Kx divided by y. Just don't forget the k. There's your first step. All right, then, right after that, they're going to give you just enough information. It says if x is 6 and y is 12, then z is 15. That gives you all the information you need except for the k, so we're going to use that to find k. All right, so it says z is 15. K, we don't know. That's what we're going to solve for. X is 6 and y is 12. Now, it's totally up to you. There's different ways you could do this. If you wanted to reduce the 6 over 12, you could do that first, or you could do, if you want to do 15 times 12, get that out of the denominator, you'd get 180 equals 6 times k, and then just divide that by 6. Either way, you should get the k value is 30. Once you have the k value, you're just going to back up to that first step and just rewrite that equation real quick, but replace the k value with what you figured out it should be. So this would be z equals 30x over y. That's a general equation for this situation. And then they're going to ask me a secondary question here. I think I used the same numbers on this one. So it says find z. So we don't know z, but I know k is 30, and then it says x is 4 and y is 9. So I'm literally just going to do that on my calculator real quick. 30 times 4 and then divide that by 9. And I did not get a nice answer, so I'm going to leave this as a fraction. This should be 40 over 3. If you want to write the decimal, it's 13.3 repeating. Does anybody have a question? We're going to try one more, and then I'm going to have you guys try a word problem here. Okay, who could set up for me? Z varies directly with x and inversely with the cube root of y. How would I write that? Directly with x, inversely with the cube root of y. Everybody's asleep this morning. What do we think? Z equals, right? Directly with x, inversely with the cube root of y. So I'm just going to do kx, that's for the direct, and then inverse, I automatically know I'm going to have a fraction, cube root of y, I'm going to write the cube root of y. Now, for the second part, we got to figure out k. So then it says x is 2, y is 27, z is a half. I'm going to go ahead and put 0.5 right there for z. You can put 1/2, whatever you want to do. I don't know k. X is 2. Now, y is 27, but the bottom of this fraction is supposed to be the cube root of y, so it would be the cube root of 27. So, does anybody remember? Maybe the top of this would be like 2k. What is the cube root of 27? Do you guys remember? It's a nice number. Grace? 3. Okay. All right, so if it was me, I would just, we're going to multiply both sides by 3, and then I'm going to divide by 2. So I'm going to do half times 3, divide by 2, and you should get the k value 0.75 or 3/4. Okay, now I want to show you 2 ways to write this, and you can just use whichever one you like better. You could, I'm sorry, we're using a z. All right, if you want to use the decimal, you could totally use the decimal, so you could do like just 0.75x over cube root of y. If you want to use the fraction, what it would look like would be you would have the 3 on the top with the x, and then you would have, bless you for the 3/4, then you'd have the 4 on the bottom with the cube root of y. Both of those would be correct. Honestly, having a decimal in a fraction like that is not super correct, but I would take either one of those. So if you want to use the decimal or if you want to use the fraction, when you have 2 parts, when you have a fraction like that, the top of the fraction goes in the top of the fraction and the bottom of the fraction goes in the bottom of the fraction if you have that inverse relationship. So whatever is easier for you. All right, so if I do 0.75 here, find z when x is 16 and y is 8. You could do it like that, or you could do 3 times 16 on the top and then 4 times cube root of 8, either way. Does anybody remember cube root of 8? Nice number? 2. Okay, so either way, cube root of 8 is equal to 2 for either method, whichever one you like better. So if I do the top one, I'm going to get 12 divided by 2, which is 6. If I do the other one, I would do like 3 times 16 on the top and then divided by 4 times 2 on the bottom. You should get the same answer either way. This should be 6. Is anybody having a question? Okay. The last 2 here, these are kind of the same concept, but it's just a little bit of a word problem. So we're going to set these up. And you might want a calculator because a couple of these have decimals. This guy says, cost of material used in making a Frisbee. So since it says the cost of material, I'm just going to use C for the cost. Varies directly with the square of its diameter. All right, and then for diameter, I'm going to just use D. Okay, so cost varies. I'm just going to put C equal. And then just automatically, don't forget this because that's the main thing. K won't be anywhere in that description, so you got to put the K in there. So in terms of this one, we're directly with the square of the diameter. So this would just be the diameter squared multiplied by your constant of variation. That would be your general setup for this. Now, from there, they're going to give you just enough information to figure out that K value. So it says it costs the manufacturer 45 cents. So I'm going to put 45 cents in for the cost. We don't know K for the material if the Frisbee has a 9-inch diameter. So the diameter is going to end up getting squared here. So we're going to have 0.45 equals 81 times your constant of variation. So we're going to take that 45 cents divided by 81. And you can see this is like a garbage decimal. So I'm just going to do my math enter here real quick to get that as a fraction. K value here, that's 1 over 180, just so we're not rounding multiple times since I had kind of a nasty decimal there. All right, so the actual then equation for any situation here, the cost is going to be 1 over 180 times your diameter squared. Another way to write that, just as an option, you could just put the diameter squared on the top and the 180 on the bottom. because we would take 1 times that diameter squared and divide it by 180. So both of those are ways you can write that. Whoops, sorry. I'm scooshing this over. Then it just says what would be the cost if we change the diameter of the Frisbee to 12 inches. So we're just going to plug it in. So if I change this to 12, it's just going to be diameter squared divided by 180. So 144 over 180. And this is talking about how much it's going to cost. So I'm going to go ahead and round this to the nearest cent. So this would be 80 cents for every Frisbee is what it would cost them. Anybody have a question? All right, we'll do one more here. Let's see. Number of bags of grass seed. I'll just use N for the number of bags. Used to reseed a yard varies directly with the area. So let me just use A for area to be seeded, but then also inversely with the weight of the bag of grass seed. So I'm going to use W for the weight. All right, so the general setup here, number of bags of grass seed we need, just automatically put a K. Don't forget to do that. Varies directly with the area. So it's going to be K times the area of this yard, and then inversely with the weight of the bag. So I'm going to put W for the weight of the bag. And you can change up these variables. I usually just use something that's in the problem so I can go back and use that to help me plug stuff in. Okay, this is tricky here. They're going to give you the number and the weight like in the same couple words here. It says it takes 2 3-pound bags. So the number of bags then is going to be 2. And also the weight of the bag is 3 pounds. So they're telling you right there, like within 2 words, that's the number of bags and the weight. To seed an area of 3,600 square feet, you don't need to do a conversion or anything like that. Just K and then 3,600. Now, however you want to do it, if you want to divide 3,600 by 3 and then multiply that on both sides, or if you want to take 2 times 3 and then divide it by 3,600, whatever's easier for you. It's not a nice number here. It's a garbage decimal again. This should end up being 1 over 600. Okay, so what that would look like, your number of bags, I would have 1 in the top with the area, so I'm just going to write area, and then I would have 600 in the bottom with the weight. I'm just going to lightly write a 1 in the top just so you guys could see. So that 1 over 600, since I have a fraction and that K value ended up being a fraction, the top of it goes in the top, which you would probably not write the 1, but the 600 is going to go in the bottom. Once you have this, we can figure out any situation going forward. So then it says, how many 3-pound bags are you going to need if you have 9,000 square feet you want to put grass seed on? All right, so how many bags? We don't know the number of bags. We know the area is now 9,000 square feet. And 1 over 600 is the K value, so I'm just going to use the 600 there. And we're still going to keep the weight of the bag at 3 pounds. Now, if you do this, do me a favor real quick. Make sure you put parentheses around the bottom. If you just type in, I'll show you, this is the wrong answer. If you just type in 9,000 divided by 600 and then times 3, that's what the calculator does. It does 9,000, it divides it by 600, and then it multiplies it by 3. So you want to figure out that product in the bottom before the division. So just put that 600 times 3 in parentheses. So it should only be 5 bags here. Is anybody having a question? Okay.